So let's revise this topic, potential flow. This video is especially designed for GATE Aerospace students. And if you want to purchase complete video series for GATE Aerospace, you can visit our website. Links are given in the description box and other contacts are also given there. You can call or you can WhatsApp, message, Facebook and Instagram is there. You can visit to description box. Let's start the topic. So we are discussing uniform flow, which is the first flow in potential flow, very basic flow. So if flow is parallel to x-axis, we consider that as u, and if flow is parallel to y-axis, we consider as v. So here I have taken our flow parallel to x-axis, and if your flow is parallel to x-axis, then dou phi by dou x will give you u. So if you will integrate both the side with respect to x, phi will be ux. So u value is nothing but v infinity. What is v infinity? Our velocity is in this direction, which is u, which is nothing but the velocity of free stream. That's why u we can replace as v infinity x. Same way, dou psi by dou y is equal to u. Phi is velocity potential, psi is stream function. So again you integrate with respect to y, we got our psi equation. Again u is equal to v infinity. Now for this uniform flow, it is actually incompressible flow. So gradient dot v is equal to 0. This is a condition for incompressibility. When you will purchase the course, there I have explained in very well manner. So every key point is there, every concept is very clearly explained. Okay, next thing is irrotational. It means cross product, or you say curl is also 0. Because irrotational, so vorticity is 0, and that's why circulation is also 0. And phi will satisfy Laplace equation for this uniform flow, and psi will also satisfy for uniform flow, Laplace equation. Now go for source flow, which is the second flow. You can also say sink flow. So for concept building, keep in mind that source flow we don't study in plane, like this we don't study. We study in 3D by keeping those sources at the axis of cylinder. So as you can see, there is a cylinder here, and here I have kept sources. All the sources are here. So if you will bother about m dot, which is mass flow rate, and which is equal to rho av. So here you see the area of cylinder, 2 pi r into length of the cylinder, correct? R is the radius, and this v we can write as vr because we have velocity only in radial direction. So that's why v I am writing as vr. So send rho down, so we got m dot rho, which is nothing but mass flow rate converted into volume flow rate, and remaining part is here. And then this new thing you divide by L, so we'll be remaining with 2 pi r vr, which is here. And then this thing v dot by L is called, this is called capital lambda. This is the strength of source, okay, and value of capital lambda is this, okay. We don't show by k, we show by capital lambda. So lambda is 2 pi r vr. So we can find out our vr value, lambda by 2 pi r. Once we got the velocity equation, now we can approach for phi and psi in same way, okay. So if we differentiate psi with respect to theta, we get radial component of velocity, and which comes as this psi value. So you can see psi is like a straight line here, like this, okay. At every theta we have different, I mean at different theta we have different psi, okay. So psi is the function of theta. You can see theta here. We got psi is the function of theta. Vr value now we can write in terms of phi also. So we got our phi also, that is velocity potential. This is in terms of r, okay. It means what? At different radius you have different phi, okay. So these are your streamlines, and these circles are your velocity potential, okay, phi, okay. So this capital lambda, which is strength of source, this unit if you will see, meter cube per second. Why? Because v dot is meter square per second. Why? Because v dot is meter cube per second, so divide by length. So we got here meter square per second. So if in case of sink, your vr you will replace by minus vr. So whatever diagram you are seeing here, arrow will be inward now. Okay, then it will be sink. Okay, so your lambda is equal to minus lambda for sink flow. Okay, again this is incompressible, but it is not incompressible at the origin. At the origin it is highly compressible, and again it is irrotational, and circulation is again 0 because vorticity is 0. Why? Because you can see here curl is 0. Again phi satisfies Laplace equation, psi also satisfies Laplace equation. Then we have our third flow, which is the combination of previous both the flows, means uniform flow and source flow. So when you combine source flow with uniform flow, we get half Rankine body. Okay, it is in oval shape. So in several books it looks like this. Okay, so here we are going to combine psi of both the flows, because this is only the way. Psi for uniform flow we already know, that is this much v infinity y. Psi for source, just now we have got this much function of theta, and after adding both we got psi for the resultant flow. Now what is important here, equation of psi we got. Now you can find out vr by using this formula, well known formula. So you will be getting this as your answer, and then you can find out v theta, which is this is your answer. Now find the coordinate of stagnation point. You can see here we have a stagnation point, because this flow is coming here and being stopped. This flow is coming here and being stopped. So this is our stagnation point, and you can see how the flow is taking turn. Okay, so how to find the coordinate of stagnation point? This is very important for gate point of view, because at stagnation point your radial velocity and angular velocity or tangential velocity, it has to be 0. Both has to be 0. So v theta is this much. So just now we have got v theta, put it 0, and you got theta value, means at theta is equal to 0 and at theta is equal to pi, you have your stagnation point. But because theta is equal to 0 will be in this direction, this is our theta actually, like this we measure our theta. So it has no sense. So but at pi we have stagnation point here. So we got pi. Now vr is equal to v cos theta, and this is the remaining form. So vr also will be 0, and just now we have got theta, substitute theta here, and we'll be getting r. Okay, means this length from your source to the stagnation point, we got our r value. So, okay, so our coordinate is r theta now. So r value is this and theta value is pi. We got it. Use this coordinate to find out equation of streamline passing through the stagnation point. So a streamline is in terms of r and theta. You can see here r and theta. So when you will substitute the value of this coordinate, then that will give you a streamline which is passing through this coordinate. So after substituting, we are getting psi is equal to lambda by 2. So this is a streamline equation which is passing through exactly through the stagnation point. Okay, so this is your stagnation point, this is your stagnation point, this is your source, and this is uniform flow. So this is the streamline equation. We have several other streamlines, but for them we have to use different r and different theta, and this used to be the standard case, special case, that's why. Okay, now we are going to see what will happen if we'll add one extra flow, that is sink also. Earlier we saw uniform flow and source, so we got half oval shape, that is half Rankine body. If you'll add sink also, then we'll be getting full Rankine body, that will be of oval shape. Earlier we got only this half part, right? Now we are getting a complete thing. So you see source I'm keeping here and sink I'm keeping here, and they are at certain distance, and that distance is not very small in as used to be in case of doublet. Okay, doublet is the next flow and upcoming flow. So now for this, how to find psi value? Again, it is very easy. Add all the three psi for uniform flow, psi for source, and psi for sink. So psi for source is this, and psi for uniform flow is this, psi for source is this, and substitute minus sign here, that will be psi for sink. And consider any point in the flow. Actually you have flow, like total you have flow. So in the flow anywhere you take any arbitrary point P, and coordinate of that arbitrary point from the origin, not from the from the origin it is theta, from the source coordinate is theta 1 and from the sink coordinate is theta 2. Okay, so equation of psi passing through point P will be given here, and you can remember, because it is a revision type video, so we have to find out OA is equal to OB. This is our A, first ignition point, and this is our O. Okay, so this much length, or you say this much length, second ignition point, is actually B square by lambda. Here you see B square plus lambda B by pi v infinity. So I have written here distance of stagnation point from origin O, both the side. So B is the distance between source and sink. Make sure what is B. Here we have source, here we have sink. So this total distance is 2B. Okay. Then equation of streamline passing through stagnation points means we have a stagnation point here. So a streamline passing through this, that is psi is equal to 0. And our stagnation point is lying either theta is equal to pi or theta is equal to 0. Okay, the above thing oval shaped, full Rankine body. Doublet formation will come if your gap will be very less. Okay, like right now in case of Rankine body we have source here and sink here. Let them come more closer, so then we frame doublet. So doublet is just one extra thing you have to add, and that is nothing but the distance. Okay, distance you decrease. So source and sink together gives doublet. So distance is very less. So but here we don't have uniform flow, because actually I have written don't be in inertia that we have uniform flow also, because we are not discussing cylinder. We are not discussing flow over cylinder, lifting cylinder, those things. Right now we are discussing only doublet. Doublet is just the combination of source and sink. So don't think that uniform flow will come here. So just source and sink only. Doublets are the family of circle. It is important because this straight line question may come. So here we have source, here we have sink, and distance is very less. So strength of source was lambda, and you just multiply with L, that will be the strength of doublet. Okay, and the new symbol we give as K. So when L tends to 0, I mean when the gap between them will be 0, the strength will be infinite. Okay. Okay, again I am repeating, I have made this video just for revision purpose, very small. So if we keep some source in the left, then we use this formula. If we keep source in the right, then we use this formula. Okay, so I hope this video is somewhat helpful, and keep on watching. Best of luck for GATE exam. Thank you.